All right, y'all. What is good, guys? Welcome, welcome. Welcome back to another stream, y'all. We're doing a pretty early stream here. Hold on, let me get my charger so I can actually, charge my phone and stuff. But I hope everyone's doing well. All right. I think we are set, ready to go. But yeah, so I decided we're gonna go live. First of all, we do have a severe thunderstorm warning in effect right now. Yes, at 5 in the morning. So I figured we're gonna do maybe a little bit of coverage, a little bit of a update here on this system that we're going to be getting later today. Because it is officially day one now. We officially have new SPC risks and stuff like that. So, anyways, good morning. Good morning, everybody. Hope everyone is well. I'm going to take a minute to get everybody in here. I know it's probably pretty weird seeing your notifications come out at 5 in the morning saying I'm live. So, but anyways, guys, but we do actually have some severe weather going on right now. Like I said, we have a severe thunderstorm warning in effect for Indiana. This is up here in Laketon, including North Manchester and Servia. I think that's how you pronounce that. We do have quarter-size hail on the storm, and winds appear to be less than 50 miles per hour. So, mostly just a little bit of a hail threat. We do have quite a bit of lightning actually being detected on this cell here. Once again, this is up in northern Indiana. We actually have another cell west of it by Fulton heading into Rochester, Indiana. Doesn't appear to be severe, but we'll have to keep an eye on that cell. What's up, Carrot? Saying good morning, bro. That storm, or that severe storm is experiencing a strong rear flank downdraft surge. We'll see what it does. Here, let's pull up the velocity here. I do see some heightened velocities, especially over by like North Manchester there. Here, let's pull up mesoanalysis. I'm curious what the environment looks like here. It's good to kind of see what we're working with, kinematic wise and instability wise here. Really not having much instability at all. This thing's running off of fumes, man. It must be some pretty steep mid-level lapse rates is probably what's going on here. We have a little bit of instability, but quite the inversion there. Wow. It's amazing that this thing could even kick off here. Let's look at the wind shear. Yeah, lower level wind shear appears to be pretty weak on that storm, about 15 knots. Winds flowing northeast here. In terms of mid-level flow, yeah, mid-level flow is pretty good. Yeah, we have about 50, 60 knots or so, which is decent. I mean, it's honestly that's just kind of a crazy little area here. Anyways. What's up, Angela? Good to see ya. It's been a while. Hi from Lansing, Illinois. Hello, my friend. Good to see ya. Hope all is well with you. Hope you're doing good. Yeah, so like I said, this morning we're actually just watching a couple storms fire off here. I mean, pretty darn early, man. Pretty darn early. Like I said, this one warning that we do have here, this is warned for hail, warned for quarter-size hail. This includes Rowan. Actually, the storm is moving out of Rowan, or has moved out of Rowan. But this includes Sydney, Indiana. This is all for Indiana, by the way. Indiana, North Manchester, Laketon, and Servia. Also, Bippus. That's that's an interesting name. Bippus. That's the first time I've ever heard of that one. See, storm relative, it shows, see the outbounds are relatively stronger than the inbounds. Huh. Here, we'll pull up storm relative velocity here. Yeah, I mean, obviously in this case, the winds is not the main concern though. Like I mentioned, quarter size hail, that is the main concern with that particular cell. Anyways, let's look at models, guys. So I was taking the beautiful thumbnail photo that we got here. We were looking at the RRFS model. Got quite a bit of a very cinematic side angle view here. But yeah, this is going to be later on today. Here's our load. So this is 8 p.m. I know you guys can't really see the time here, can you? There you go. All right, now you should be able to see the time in the bottom left. You see where it says 5 p.m. Eastern, EST, Eastern Standard Time? So this is where you can see the time down here in the bottom left. Anyways, but yeah, I mean, so according to this model, it looks like we'll start getting convection. I mean, obviously we have some pretty early right now. You know what's crazy? The RRFS model, so obviously right now it's 5:30 almost. This is for 5 o'clock in the morning on the 06 UTC run. Not really showing much of anything in Indiana, but it does show some convection at like 9, 10 o'clock in the morning. We're early. This is early, man. Like, here's current radar we're on now. Oh, we actually got a new warning here. Oh, there goes that back one we were talking about. Yep. So that finally went warned. But that includes Rochester, Indiana, including Mentone, Burkett, Claypool, Silver Lake, and Akron. Also for quarter-sized hail. So yeah, both of these severe thunderstorm warnings up here in northern Indiana. These are both for quarter hail. Now, you want to know something crazy? The temperature on the ground, ready for it, is 43 degrees. Bit of a cold core setup here, as you can kind of tell. But yeah, hazard is quarter size hail. Like we mentioned in the earlier in the stream, if you guys weren't here, cold core setups typically are more prone to producing hail, partially because freezing levels lower, in the convection. But yeah, in this case, we definitely do have quarter size hail. Definitely interesting. So yeah, we're gonna keep a close eye on these guys here. They shouldn't do anything tornadic, these ones. Obviously, the threat, like I said, later on today, we are going to have a bit of a tornado concern, though. So speaking of models, we work our way down in time. So this is really showing a lot of that convection popping off here. From the RRFS model, anywhere from 1 to 2 p.m. or so, or 1 to 3 p.m. You can see a bunch of cells pop off here. Very scattered from the way that it looks here. So this is for 3 p.m., then we go into 4, 5 o'clock p.m. We start to get some more cells. And it seems like the RRFS model now shows kind of a bit of a little line of storms. You see that? I don't think that was there when we looked at it yesterday. I mean, literally the last stream we did, I don't think we saw that. But we do have a bit of a line here of quite a few cells, man. Interesting. If it did something tornadic somehow, I'm convinced life is a simulation. Yeah, no, it's way too elevated. Way too elevated. I mean, I'm sure the storm base on this thing is like thousands of feet high. So I don't think so. I don't think so. Let's see, where are those 3 p.m. cells? Let's see. Hold on. What I'm going to chase here. Oh, you made a typo. I meant where those 3 p.m. cells are is where I'm going to chase it. Oh, okay. Gotcha. Well, there's a lot of them. Yeah, models, they're still a little iffy, as you can see. There's the RRFS model that we're looking at here. And if we look at the HRRR, we'll go back to the HRRR here in the 06 UTC run. It does show kind of a similar story. You know what's interesting is that something new, it seems, between these models here. Let me duplicate this here. We'll pull up the RRFS model on the right panel and the HRRR on the left panel. How about that? That way we'll have like a direct. Let's see. That way we'll have like a direct view between the two models. So once again, RRFS on the right. Here, let's change the model. There we go. All right, so RRFS on the right, HRRR on the left here. So you can obviously see the two models in agreement. I'm also going to go back to the 06 UTC run on both of these guys. So timing, I mean, obviously we're going to be having a little bit of convection even, or this morning. I mean, obviously right now, we got a new warning actually. Right now, obviously you can see in northern Indiana, we already have stuff firing off. We do have a new severe thunderstorm warning now in effect for northeast Indiana for Columbia City, Tri-Lakes, South Whitley, and Larville. Quarter-sized hail. And wind should be less than 50 miles an hour. We might have a little bit of gusty winds on it, but the main threat here is hail. But anyways, what I was saying here though is that comparing the HRRR on the left and the RRFS on the right, I mean, we do have some early convection, up here in northern Indiana, obviously, which is happening now. A little bit early though. Yeah, I mean, really, like, look at that. Hardly any models had that happening at this point. I mean, the closest one that got it was the RRFS model. A couple of hours delayed, actually. So we're early. We're early to the show. That just goes to show you models ain't perfect. Definitely interesting, though. But yeah, we go to 3 p.m. here, and you can see that it seems like we have a lot more cellular activity on the HRRR versus the RRFS model. The HRRR does have more cells. It also shows a lot of convection in Indiana. Meanwhile, the RRFS is still pretty silent. I mean, so it's pretty obvious here that where these storms are going to be is a little bit iffy on the models. I mean, even in the nowcasting side of things, there's cells here when the model said that there wouldn't be. So that's interesting. Carrot says there's definitely been an uptrend in southern Indiana and northern Kentucky, growing a tiny bit more concerned. Let my family know. They need to watch for the weather. Absolutely. Absolutely. James says, you're in central Kentucky, and my threat's mostly winds, maybe some small hail, but it's worth a shot to go chasing for some stuff. Well, be careful, dude, if you do. I mean, definitely just want to make sure you're staying safe. Also, we got a new cell developing. Look at that, right behind the severe warn one. Wow, that just popped up out of nowhere. And that came up pretty quick, too. Look at that. So, wouldn't be surprised if in the future this does go warned as well. If it continues on the trend it's going, I mean, obviously it's strengthening. We went from that to the next frame being that to now that. So it's on a strengthening trend. I mean, that's pretty obvious. So, yeah, we'll have to see. That one might actually go. See, wind's going to be the big threat. Yeah, the winds are going to be the biggest concern. The winds and hail have an equal probability of severity per SPC today, both in the 15% region. Tornadoes will be a possibility, too. Rockus says one of the Lafayette, Indiana weathermen was using the HRRR and said that I would get really bad weather in Lafayette, too. Gotcha. Well, I will tell you this. The models are very much in disagreement mode right now. I mean, a prime example right in front of you. We got the HRRR at 3 p.m. on the left. Both models are at 3 p.m., by the way, as you can see. I'll even move this up here so you can see. So both of them are at 3 p.m. You can see my mouse here. 3 p.m. on the RRFS, 3 p.m. on the HRRR. HRRR shows convection all through central southern Indiana, while it's crickets for the RRFS model. So that in itself is interesting. They're obviously different on timing. Then you got the HRRR right at 8 p.m. Eastern showing convection in West Ohio, while it's mostly crickets in West Ohio from the RRFS model. It almost seems like the central low is off-centered. Or not off-centered, but, different. You know what I'm saying? Like, you can see, for example, the central low is right here on the HRRR, and the central low is more right in here for the RRFS. So there's obviously a little bit of difference there. Actually, a lot of difference. So, yeah, these multicellular events are a little bit more tricky to forecast timing for, because it's hard, knowing exactly where each cell is. I mean, the models don't really know that. I mean, once again, prime example right now, we actually have convection. Oh, there goes that other severe warning. I knew it. I knew it would. So, new severe thunderstorm warning for northern Indiana, including Macy, Denver, and Rowan. Quarter-size hail. Yeah, so these are all warned for. We have 3 severe thunderstorm warnings. These are all warned for quarter-size hail. So hail up to 1 inch in diameter. And there could be a little bit of gusty winds on them, but if we did get some gusty winds, it would be less than 50 miles an hour. So nothing quote-unquote severe. But definitely in terms of hail, though, there is potential. What's up, Bluegrass? Good to see you. Seems with this cold core stuff, these storms are getting their hail cores quickly. Yeah, absolutely. Yeah, I mean, like I said, there's got to be some steep mid-level lapse rates or something going on here. Let's pull back up our meso analysis real quick. I should be able to look at lapse rates. I think between 2 and 6 kilometer lapse rates. Okay, so we're between 6 and 8 degrees Celsius per kilometer. That explains it. I mean, lapse rates are higher up here. Here, let me go back to models. We're going to go back to the one panel. I'm curious to see what the models suggest these lapse rates are this morning. So, like I mentioned, lapse rates basically just shows you how much the temperature is dropping off over altitude, the rate at which temperature drops off over altitude. So that's what we're looking at here. Thermodynamics, let's do... I might have to just pull a sounding so we can get all the information here. All right, we'll do like 5. Actually, you know what? Current time here now is... What time is it? So it's 5:30 right now. So we'll... I mean, obviously it got the environment a little bit iffy. Because, I mean, there's cells firing off now when the models, both HRRR or RRFS, didn't really show it. Wow, look at that steep temperature inversion. That's crazy. Yeah, at the ground, I mean, you can see dew points are probably in the 20s here. Temperatures upper 30s, lower 40s. Then you go up, like 1,000 feet or so, while the temperature on the ground is 38 degrees. Temperature 1,000 feet up is 52 degrees. So, I mean, it's very elevated. These storms here are very elevated, meaning the storm base is pretty high up, which would not support tornadoes. So don't worry about these. These ain't going to do tornadic activity. But I mean, also lower level winds are pretty weak too, so I don't see that being a problem. However, wow. Look at this, 850 to 500 millibar lapse rates of 8.1 degrees Celsius per kilometer. Now, you guys are probably like, what the heck? Basically, what that means is that the temperature is dropping off very quickly over those layers. So we said from 850, which is from this level, about, we'll do American units, so that you guys can see what we're looking at. So pretty much from 4,000 feet up to about 17,000 feet. So between 4,000 and 17,000 feet, the temperature is going off quick. You can really see those lapse rates there. We even have a bit of instability here. That's where you got that positive buoyancy. Negative buoyancy, where the air is wanting to rise. Wow, those are some pretty cold mid-levels too, though. I'm sorry, I'm just kind of like nerding out here a little bit. But yeah, I mean, Very elevated storms, though. Like I said, that would not be be a tornado concern. So don't worry about it. But still, really interesting to see. And I mean, obviously the shear at this level is pretty high too. So I mean, it makes total sense why these storms are firing off. I mean, even in the environment that we're in, it's. Oh my gosh, we have a new cell. Hold on a minute. We got a new cell firing off behind that new one. Wow, look at that. All right, there we go. We got a new cell. Don't be surprised if that one even picks up quite a bit. Actually, we have two new cells, or a few new cells, I should say. One over by Logan Sport there, and another one out by Burnettsville. So there's one here, there's one here. Like I said, quite a bit of lightning activity being detected on here. Carrot says the presence of convection this early might be a sign that general forcing might be a little bit better at first glance. I mean, like I said, those lapse rates, they're not shallow. They're pretty steep. That's pretty wild. Good morning, Tabletop. Hope you're doing well. Kind of worried about my area Saturday. Any thoughts? I don't think we even have a risk for Saturday, if I'm not mistaken. Let me pull up. So what's today? Today is Thursday. Okay, so today is day 1. Day 2 is Friday. Day 3 Saturday. Okay. Oh, you know what? They did actually. Look at that. That's new. Sorry, I'm just now learning this. Apparently, we now have a marginal risk here. Yeah, I literally this is the first time I saw this risk here. Holy cow. All right, well, yeah, you're in a marginal. I wouldn't worry about it too much. I mean, it's a level 1 threat. It's nothing to ignore, obviously, but we'll keep an eye on it. Interesting. Very interesting. Let's see. Raka says, but as the day warms, what do I think will happen? That's a really good, question. So yeah, obviously as the surface warms, that'll increase your lower level lapse rate, which could obviously allow for more storms to fire off here, which is, I mean, kind of explains the mode and why we have, a bunch of multi-cellular storms later today, So, I mean, yeah, I mean, it makes a lot of sense here. Here, let's bring back up our radar. Oops. We'll do this radar. Here we go. Interesting. Yeah, there's a lot of storms here. And like I said, this is probably going to be more of a for some areas, some people are going to get more than one storm. So, but yeah, no, as the daylight, as we do get diurnal heating, as the surface heats up, it will definitely make the environment more potent for storms and severe weather in general. Because, I mean, yeah, kind of like where we're at right now, I mean, you could see in the lower atmosphere. So this is the ground level, temperature in the 40s. And you can see how, as you go up in altitude, the temperature actually gets warmer than it is on the ground. But as the daylight comes, or as the sun comes out, you can see everything starts to heat up, which makes it more steeper lapse rates, which will set us up for a decent environment here for storms. We'll definitely keep a close eye on that. And once again, tornadoes, large hail damaging winds are all on the table here. Let's see, the storm is warned for 1.5 inches earlier. Really? Gotcha. Here, let's hop back to current radar. So we have a group of severe thunderstorm warnings right now in effect for northern Indiana. Also got a new cell, like I said, starting to pop off here out by Media. It's west of Mexico, not the country of Mexico, but the town of Mexico, west of Denver, not Denver, Colorado. Can I get a town or something that actually makes sense? North of Logansport there, here in north central Indiana. There we go. What's up, GTA? Good to see you, man. Hope you're doing well. Been subbed and about to share. Well, thank you. Appreciate it. Appreciate it. Logan says, let's see, heading just east of St. Louis currently for target. Oh, gotcha. Well, be careful, dude. Please be careful. Yeah, I mean, if you're out chasing this, I mean, you gotta be really careful. All right, let's hop back over here. I do want to take a look back at our environment. So, I mean, I read this wrong. This is 7.5 degrees Celsius lapse rates between 2 and 6 kilometers. So that's pretty darn steep. So all of this is elevated convection. And like I said, what I mean by elevated convection is the base, storm base, typically for like tornadic activity and stuff. I mean, you want the storm base to be pretty shallow, pretty low to the ground. But in this case, being it's elevated, while the surface conditions are kind of trash for convection and for thunderstorm activity, the conditions up above are better. And we just so happen to get convection going on right now, you know? So, I mean, I totally see why. I mean, this is a classic cold core setup right here. Like I said, tornadoes, though, I wouldn't worry about because of the fact these storms are elevated right now. Later on today, though, like I said, I mean, that's going to change. But for right now, for these particular cells, I wouldn't worry about it, you know, being tornadic or anything like that. But it's really interesting, though. Let's see here. Carrot, what was the DBZ? What was it at? You said maxed out? That had to have been, like, really high. Let's see. JT, what's up? Good morning to ya. Hope you're doing well. Good to see ya. But anyways, like I said, if we were to grab a sounding in this environment, we don't have a weather balloon launch for another, an hour or so. But if I was to grab sounding based off of, model data, let's see. The storm is west of Fort Wayne here, so it's up by Columbia City. Okay. So these cells are right here at this point. We're going to go back to 5 a.m. So this roughly gives us what the atmosphere looks like. So, yeah, I mean, on the lapse rates here, I mean, you can see that they're pretty steep. They're pretty steep in the mid-levels. But once again, our lower levels here, I mean, we're pretty cold. You know, temperatures here in the lower 30s. Dew points in the lower 30s. Temperatures in the mid-upper 30s here. But once again, I mean, that's at ground level, so temperature upper 30s. As you go up in altitude, we'll go up to about 1,000 feet. The temperature is 52. So it's weird. The temperature, gets warmer. It's a temperature inversion there. Temperature actually gets warmer as you go up 1,000 foot, which typically you'd think it would be the opposite. But in this case, in this environment, it's not. But then, like I said, the temperature just drops off so fast. That's actually creating some instability in the mid-atmosphere. And, I mean, it's doing it. It's doing it. And, let's see here. With the lapse rates, I can't get over those lapse rates, dude. Between 3 kilometers high and 6 kilometers. So, between these two layers here, which is kind of your hail growth layer, we are seeing those lapse rates about 7.4 degrees Celsius per kilometer, which decent. But then you got 850 to 500 millibar lapse rates, which is 8 degrees Celsius per kilometer. That's pretty high. Once again, the temperatures are just dropping off dramatically over altitude, more than they normally would, which is creating a pretty unstable environment, which is why we're getting convection. Now, the models obviously didn't pick up on this, but Mother Nature said otherwise. Once again, I mean, it literally goes to show you these models ain't perfect. But really interesting stuff, though. Really, really interesting. By the way, guys, if y'all do enjoy this video, or live stream, I should say, not a video, but if you do enjoy the live, be sure to leave a like if you all could. Maybe subscribe if you're new. It'd be much appreciated. And if you guys have any questions, feel free to throw them down in the chat. Okay, so we got some new updates on the warnings here. We did just lose the warning to the north. So that severe thunderstorm warning that was in effect for Rochester, Indiana, Mentone, Indiana, Burkett, Indiana, Claypool, Indiana, and Silver Lake, Indiana has been canceled. The storm appears to be losing some strength here. Yeah, it appears to be dismantling a bit. You can see we did have some pretty high-end DBZ, pretty good reflectivity, and then later scans suggest that the precipitation intensity is decreasing, which honestly, even dying storms can have more hail because it basically drops all the hail that was within the storm because updraft weekends and stuff like that. Really interesting. Logan says for sure. I'd chase all over. Been to the Midwest lots in the Dixie. Gotcha. Well, just always be careful, dude. All right, so we do have 2 severe warnings. We have one for, once again, this is all for Indiana, by the way, y'all. The active storms right now, you can see here's Indiana, like here's South Bend up here, here's Fort Wayne. Here, you can just kind of see how in relation to the states where we're at here. So we zoom in. This includes Columbia City, Tri-Lakes, this severe warning, Laud, South Whitley. Sydney's almost out of it, but we actually have another storm coming up towards Sydney. This warning here, this is for quarter-sized hail, so potential hail up to 1 inch in diameter. Max wind gusts here less than 50 miles per hour, 50 or less. So not damaging on the winds, not severe on the winds, I should say, but we do have severity in hail. Now, the other storm that we have just southwest, actually, we have a new warning. Look at that. New warning now including North Manchester, Indiana, and Laketon, Indiana for quarter-size hail. Would you have ever guessed? Quarter hail, less than 50-mile-an-hour winds there. Angela says, thanks for going live, Sarasota, Florida. You're very welcome. No problem. Proxy says, what caused these cells to fire? I wasn't expecting cells right now. Steep lapse rates, very steep lapse rates. So we are actually just looking at the models here. I mean, even though the models didn't show convection, this is roughly giving us an idea of what the environment looks like right now. But you can kind of see it, you know? We have a decent amount of instability here, at least mid-level instability. Mixed layer, kind of low, but most unstable cape is pretty high. I wouldn't say, extremely high, but high enough for storms. But, even though the ground here is very cold, both on dew points, low in moisture, as well as low on just temperature, not much heat on the surface, excuse me, like we mentioned here, the temperature, it just drops off dramatically over a short altitude difference. Once again, you can see down here on this little box, LR stands for lapse rates. Once again, lapse rates is basically telling us the rate at which temperature is dropping over altitude. How quickly the temperature is dropping off, the higher we go up in altitude. And that number is very great right now, very high. And because the air is cooling off so quickly, it's allowing for this the updraft, the warm air that's rising to be cooler, or the warm air that's rising is warmer than the environment is around it. So the environment around the warm rising air is cooler. Obviously, hot air wants to rise, cold air wants to sink, basic density. And these lapse rates are creating an environment where you have negative buoyancy, where the air wants to go upwards. So that's creating your updrafts, and that's obviously allowing, or in this case, allowing for the storms to fire off here. Hopefully that makes sense, but that's a big part of it, is the lapse rates. The wind shear too is another big part. Really strong winds at the level of convection. We're talking, pretty decent winds. Some levels could 70, 80 knots or so. You can see the LFC. That stands level, or that's level of free convection. That would be roughly where your LCL is what I want to go off of. Lifted condensation level. That's pretty much where your storm base would be. And like I said, in this case, these storms are pretty darn elevated, meaning that the storm base is high, which is not good for tornadoes. So we're not going to get any tornadoes out of these ones, don't worry. But what this does enable is, because of how cold the mid-levels are, it enables the fact that we could have some hail involved. Because we have a decent amount of instability, and just because of how cold the air is at these levels, lower freezing points, lower wet bulb zero, stuff like that, really allows for hail to exist and be dominant in these storms. And that's really kind of what we're seeing right now. That's obviously that's what these are warned at, what these are warned for right now. These are all quarter-sized hail warnings. None of these are for damaging winds or tornadoes, obviously. So it's definitely a very unique environment I will say that, this is one of your classic cold core type of setups, which, I mean, it's pretty cool to see. Definitely pretty cool to see. Car Medic says, finally you're live again. I'm here. What's up? Good to see you. See, for the last 5 hours, it's been severe thunderstorm warnings. Yeah, I've been noticing quite a few of them. Like I said, I wanted to go live here, obviously to talk about these early storms, but also to give you guys a bit of a heads up once again. Also for today, today we're gonna have a pretty busy day out there. We do have a level 2 threat from the SPC. So let's bring up the threat here for today. Actually, yeah, tomorrow we have a threat as well for the south, and day 3. So actually, we're going to be pretty busy the next couple of days. But yeah, here's today's threat, in which you can see the main areas involved. The highest risk area today is going to be central southern Illinois, central southern Indiana, southwest Ohio, and northern Kentucky. Now, the overall severe weather threat does extend into portions of eastern Missouri in the dark green. The dark green is the lowest severe weather risk today. The yellow is the greatest severe weather risk today. So anywhere in the dark green and the yellow, there is potential for severe weather today. Anyway, so then we have the tornado threat, which we still have a 5% chance for tornadoes, greatest probability for tornadic activities, mostly going to be central southern Illinois, central southern Indiana, bits of northern Kentucky, and southwest Ohio. But the overall tornado threat extends into southern Kentucky, eastern Missouri, into central Ohio, including like Columbus and Dayton, Cincinnati. These areas are in that tornado risk here too. 5% chance for tornadoes in the brown. Every 25 miles, you have a 5% chance of a tornado dropping within that radius. So 5% chance in the brown, 2% chance in the green. Damaging winds, we have a big 15% yellow area here. You can see where these states are involved, including some populated areas like Springfield, Illinois, Indianapolis, Indiana, Evansville, Indiana, Louisville, Kentucky, Dayton, Ohio, Cincinnati, Ohio. So these areas are in the 15% risk here, where we could see damaging winds. What the winds could peak up to within these storms could peak for a couple seconds upwards of 60 miles per hour. That's the kind of a thing I was explaining to you guys earlier too. It's like, overall, it's like, essentially, sustained winds means, constant winds of a given number. And whenever people think of 60-mile-an-hour winds, within these storms, they think of constant winds blowing at 60 miles an hour for a long period of time. No. What we mean by 60-mile-per-hour wind gusts is what the winds could peak up to, usually for a couple of seconds. They could gust. The strongest winds could peak up to about 60 miles an hour or so for a couple of seconds. It is possible. Let's see here. Yeah, Carrot, possibly. Like I said, this is just kind of one of those little rare. Not super rare, but you know what I mean. One of those unique setups here this morning. It's very interesting. I'm really glad I went live though to cover this. Let's see here. You're stayed away from this. Gotcha. Well, that's good at least. At least you're not involved in the nasty stuff for today. Carrot says, see, I wouldn't rule out an upgrade if confidence in storm initiation grows. But because this day, see, is Nowcasting type, it doesn't really matter. Yeah, we'll see. Once again, the main thing. What's really limiting today's severe weather events? Well, first of all, let's bring up our checklist. So we have the 4 main things for severe weather and thunderstorms mostly to develop. You need wind shear, which wind shear is essentially just winds at different altitudes, the wind speed, wind direction at different altitudes, wind shear. Then you have moisture. We measure that in our dew point, typically, on the surface, the amount of moisture available for these storms. Then you have instability, which is, how much unstable air there is for these storms. And then, of course, we do have lift. So getting that warm air that's on the ground up into the cooler environment above. So all these are really important factors for severe weather and stuff like that. So we have a lot of wind shear. Our wind shear is very strong. I can even show you right now. If we bring up the lower level, I'll go ahead and show you guys the differences here. We'll bring up our lower level winds. So 850 millibar winds. So this is 4,000-ish feet up. And you can see, I mean, right now across Kentucky, more than likely they're not really anything crazy. I mean, right now we're probably seeing 15, 20 knot winds across Kentucky at 4,000 feet, which is nothing much. However, as we go later on into the evening, that changes dramatically. You can see that these winds increase to about 45 to 50 knots at 4,000 feet, roughly. These winds really do ramp up in speed. And direction's very important too, which I'll get to that in a second. But, for the lower level winds, the winds are flowing in this direction, right? So then we're going to bump our winds up a little bit higher. We're going to go up to about 700 millibars, so a little bit higher up in the atmosphere. And one thing, I mean, not super much higher, but you can see the winds are mostly flowing. Actually, we're going to go up to 500 millibars here, which is roughly about 17,000 feet or so. So now going up that high, you can now notice how the wind direction has changed. The winds are more flowing eastward. So there's obviously a bit of a change in wind direction, but also in wind speed. Because remember, those lower level winds at about 4,000 feet were blowing at about 45, 50 knots. Meanwhile, the winds at about 17,000 feet are moving about 75 knots or so, which that's definitely stronger in wind speed, but also, that change in wind direction. So, and also between the surface, we're looking pretty high here, looking at 500 millibars. But also, I mean, like looking at the surface here, towards the ground level. If we were actually to bring that up real quickly, we'll do that real fast. Looking towards the ground, I mean, we'll do 10 meter wind speed here, towards ground level, for right around this time. I mean, obviously they're not anything, extreme, but they are about 15 to 20 knots or so. So here on the ground, this is 10 meter. This is actually 30 feet up, but, roughly pretty close to the ground. You can see these winds are moving pretty much northeast here, northeast maybe. And then now we bring up the 4,000 foot, wind speeds here, in which they are a little bit more further northeast, and the wind speeds are stronger. So, like I mentioned, there is that varying wind pattern there that we have. So that's important for tornadic activity. Anyways, but what I was getting to is that we have a really good wind sheared environment, meaning that the winds throughout the atmosphere are very strong and they're in the right orientation for severe weather, including tornadoes. The next thing is moisture. Looking at these dew points here, this is our moisture content. Typically for, organized severe weather events and stuff like that, you'd really want those dew points to be in the 60s and the 70s, overall. And for today, we're going to be having those dew points in upper 50s, lower 60s, which, yeah, I mean, that's enough moisture. Because like I was explaining earlier, warmer air holds more moisture content, holds more water vapor, right? Colder air holds less water vapor than warmer air. So given that the ground is warmer than the air above, also remember, warm air wants to rise, cold air wants to sink. Given that we have more moisture in the environment on the lower atmosphere, and once that air starts rising up into the colder atmosphere above, the air can't hold that moisture anymore, so it releases it. It condenses and it turns into water droplets, which is why you get these clouds that form, and eventually, once they become heavy enough, they become full-blown storms. Once again, because simply, a lot of the moisture is being supplied from the surface, from the ground levels, which really fuels is what I meant to say, really fuels these storms here. Car Medic says you're in the general risk. Gotcha. Yeah, well, you should be fine. I mean, maybe a couple booms of thunder is what that means, but nothing severe. But bottom line, I mean, like I said, moisture content seems to be pretty good. Dew points being right at around 60 enables enough moisture to, allow for convection to continue on. So once again, strong wind shear we have, good moisture content. The next thing is instability. Now, here's where things become a little bit iffy on this system. If we had more instability, we measure this, in CAPE, convective available potential energy. If we had more CAPE, that would really allow for there to be more buoyancy. So that air that's rising would be a lot more aggressive going upwards if we had more instability. Now, we have enough. Don't get me wrong. We have enough instability, enough to get the job done, whatever. But it really seems like that's really where a lot of the limiting factors come in here. Actually, it looks like by this afternoon, the HRRR has increased the amount of instability. Actually, decent over. I'm gonna cherry pick a sounding. Don't judge me. I'm just curious to see what this lapse rates look like. Wow, holy cow! This is in a perfect scenario right here, but definitely quite unstable. Anyways, there is enough instability for storms. Enough unstable air for these storms to fire off. So there's that. And then lastly, in terms of lift, obviously we have this cold front kind of pushing everything out. So that alone is going to be, allowing for bits of, or a bit of lift to occur. I don't know if there's vertical velocity on here. I haven't really checked on this program. Oh, here we go. Vertical velocity. We'll do 925 millibar vertical velocity. There you go. So some areas can achieve lift. Not necessarily always from boundary, not just from cold fronts and stuff like that, but also from uneven heating. So say one area, one portion of ground heats up more than the other. So obviously, the ground heating up causes the air to rise up. So that's a good start to get some storms going. With that warm, moisture-filled air rising upwards because it heats up quite a bit because of the sun, and it enters the environment where the surrounding air from the so obviously you have the air that's rising. The surrounding air in the environment is cooler than the rising warm air. So it keeps on going upwards because, once again, hot air rises, cold air sinks. So, this is allowing for the warm air to continually rise. But besides that, we do have, obviously, enough lift here. There's some spots to have decent amounts of lift here, especially as we work our way into later this afternoon, where we unevenly heat up the surface. Could create some pockets of lift, which could, allow for some isolated storms to just randomly pop off. So that's that. That's that. Let's see. The general risk doesn't mean zero severe risk, but it's below even marginal thresholds. Yeah, the general risk typically just means that you could see a few thunderstorms. We can't rule out thunderstorms. A couple of booms of thunder can't be ruled out. Now, yes, you're right. I have seen events where severe thunderstorms have exceeded out of the marginal risk area into the general thunderstorm risk. A lot of that is just because, forecasts, they're not perfect either always. And so we are expecting the general amount of severe weather to be contained within the marginal risk and greater. But no, the general severe thunderstorm, or sorry, not severe thunderstorm, the general thunderstorm risk isn't a level for severity, really. It's more there just to say this area could see storms potentially, just based off the environment. But yeah, once you go into marginal, that's when you have that level 1 threat. That's where the severe threat becomes, and that's where we do have, potential for damaging storms, severe thunderstorms, and stuff like that. Anyways. But yeah, so like I said, bottom line, we have great amount of moisture, obviously nothing excessive, but we have enough moisture, good amount of moisture, so that checks off the box. We have good wind shear, pretty darn strong winds throughout the atmosphere, not just on mid levels or lower levels. Pretty darn windy throughout the atmosphere, and of course the veering winds, the changing winds in the lower atmosphere, which is important for tornadic activity. So we have that. We have moisture, good amounts of wind shear. We have good lift, uneven heating of the surface. Some areas could see some pop-up storms, and of course the cold front coming through could kind of sweep up everything else. And then of course, instability. The CAPE, convective available potential energy that we have. The CAPE there, essentially, it could be better. We have enough instability, enough unstable air for to support severe thunderstorms. But that's really the main lacking sector for this event. If we had more instability, like I said, if we had more CAPE, I feel like this could be a lot more stronger of an event. And the reason we don't have that high of CAPE, convective available potential energy, is because of weaker lapse rates. We talked about lapse rates earlier, basically the rate at which the temperature drops off with altitude. And our lapse rates, they're not super, I don't know, not the best for really strong severe storms. They could be better. But if we had steeper lapse rates and stuff like that, then that would create more CAPE. That would give an environment where more CAPE would be likely. Anyways, Janice, what's up? Good to see you. Saying hi, Andrew. Stay safe today. I'll be all right. I'm not into severe storms or anything, so I'm thankful for that. Carrot says, if the other models agreed with the HRRR, I'd be concerned. Yeah, there's obviously quite a bit of disagreement though between these models. Here, we'll bring back up our future radar here. All right, let's do this. We'll do my color maps. We'll turn back on our. Let's get rid of this pen here. I always keep drawing by accident. Anyways, but yeah, so I mean the main event starts. It appears pretty much early afternoon from the HRRR. Just a big clump of scattered storms, which obviously some of these could be severe for all hazards. Once again, tornadoes, large hail damaging winds. So that's 2 p.m. here for today. Then we work our way down into basically around 4 o'clock p.m. According to the HRRR, we do have maybe some more. Maybe some more stronger storms here, more severe storms here, maybe a little bit better organized, at, early evening, 4 p.m. or so. Then we transition into about 10 o'clock p.m. or so. A lot of the convection works eastward into like Ohio, Indiana, likely still seeing a couple scattered severe storms. But then what's interesting is that the HRRR does kind of show maybe a little bit of a line developing here, which, I mean, that's pretty new. If we compare that with the RRFS model here, as we do get later down into the, right around the same time or so, you can kind of see that line does develop. Now, I noticed the timing and stuff like that between the two models is a little bit different. But, I mean, from the way that both of these models are depicting the system, shows it mostly a multicellular event, bunch of scattered storms. Which, a couple of them could be severe, could be, strong to severe. Now, I want to remind you that, just because you're in the risk area also does not mean that you're guaranteed to see severe weather. So I want to make that clear. The risk area here is where we do expect the majority of these severe storms to be contained within. This is where the environment is greatest for severe thunderstorm activity, based off of everything we've talked about here this morning. So, I mean, it's definitely a decent little setup here. But the greatest concern once again here is in the yellow, which is a slight risk here, that level 2 threat. Which includes Illinois, Indiana, Ohio, portions of Kentucky here. Some pretty big cities included, like Louisville, Kentucky, Springfield, Illinois, Bloomington, Illinois, Indianapolis, Indiana, Dayton, Ohio, Cincinnati, Ohio. Just shy, honestly, for East St. Louis on the Illinois side is actually in that risk area too, in the level 2 threat. So that's where the greatest potential is for today. Carrot says just erase the storms, bro. I wish I could, but I ain't gonna lie. I mean, some of these places really do need the rain, though. They have a really bad drought in some of these areas here. So I know a lot of y'all need the rain, but minus the tornadoes, minus the damaging winds and stuff like that. That would be good. Yeah, because we don't want any of that. But anyway, so yeah, so then we move our way down. Like I said, we should start to see some storms firing off here, kind of in the early afternoon, going into early evening. Should start to see a bunch of storms firing off. I'm going to grab a sounding. This is for 5 p.m. today in southern Illinois, ahead of a couple of cells here. I should also mention that this is, I believe, the RRFS model. So the one thing I notice here, right off the bat, so the first thing I look at is our moisture content. So we have 59-degree dew points, which is going to be supplying enough moisture for convection for storms, for these storms in general. The second thing I look at is the wind shear here too, and also the CAPE. I mean, we don't have any warm layers that's going to prevent any convection, so that's good in this environment, anyways. But look at our hodograph. We have a little bit of a hook. You can kind of see here, a little bit of an arch. So that's telling us that the wind speed is increasing with altitude and also changing direction with altitude. The winds are changing direction, which you can also see on our little wind barb flags here. Down at the lower levels towards the ground, actually, the winds are flowing from the south to the north. You go up a little bit in altitude and the winds change directions to the northeast and also increasing in wind speed. So speeds down here are low, speeds up here are higher. The winds down here are pointing north, winds up here are pointing northeast. So that creates some spin in the environment there. There's enough instability for a positive or negative buoyancy, for basically the warm air that's rising to continue to rise up until the equilibrium level, which is right here. So storm tops would be, in this case, roughly about 9 kilometers or so. I mean, they might go a little bit higher because of updrafts kind of pushing past the EL temporarily. But anyways, I mean, overall, the environment is capable for tornadoes, stuff like that. So definitely got to keep an eye out there for that. Let's look at the effective inflow. Okay, storm relative helicity, effective inflow layer is showing 320, which that's decent. That's decent. Decent spin, based off of the wind shear and stuff like that. How do I think the lightning will be in this? Says Raka. Probably pretty good, actually. I mean, we're already seeing some pretty active lightning here. I mean, the event hasn't even really started. We actually have some pretty early convection here. This is a different type of setup than later today. This is a cold core setup, mostly because of steep lapse rates in our lower mid atmosphere. The event that we're going to get later today is more of a traditional convective system. But, even later today, I think we're going to have decent lightning activity. Absolutely. I mean, just given how we're set up here overall. But anyways. Let's see here. Carrot says the storms can't consent to being erased. They don't have any. Yeah, that's true. That is true, I guess. I mean, yeah, storms don't have feelings after all, do they? I mean, if they did, I think they'd be a little bit more considerate on what they do to people's homes and stuff. So, yeah. Unfortunately, they don't. Or I'm kind of glad they don't, actually, now that I think about it. Could you imagine? I did not expect that to be in the topic this morning. If storms had feelings, that would be something else, man. Something else. All right, y'all. Let's take a peek at the current sat view. We're gonna go back to Nowcasting for a minute. I want to look here. Do I think it'll go 10 sig? I don't think so, personally. Here, let's bring up our satellite imagery. It looks like we might even have a little bit of fog out here this morning. You can kind of see where the blue is here on geocolor. Looks like we might have a little bit of fog here. It's interesting though. You can see the flow to the northeast here. Here, let's bring back up our models for a moment. I do want to look at when that low really strengthens here. So now we're bringing up our mean sea level pressure. Yep, so we have a pretty strong low. There you go. You can see right now it's like over Kansas at the moment, roughly. You know what? We're on GFS. Let's drop back to the RRFS model. Yeah, so right now the central low, the middle of that low pressure system is over like Kansas, and will work its way over here to the northeast here. Might get a little bit of strengthening in that low as the system does such. But basically what's happening here is, we have this main low, right? So we have the low pressure. And since these guys rotate counterclockwise in the northern hemisphere, because of the Coriolis effect, we do actually have cooler air coming downwards, from up north. We have our cold front. And then the opposite happens ahead of the front here, because it's actually dragging up warmer air. So we actually have a bit of warmer air being dragged upwards. And, we're getting a lot of our moisture from the Gulf here. Obviously the waters keep things pretty moist down here. And because of this low is kind of tugging on the air from down south upwards, up to the north, it's increasing moisture content, which helps for these storms here. So we're getting some of our moisture from the Gulf here for the system. Let's see. Gary, South Dakota's possible exception. Missed every home, but had a grudge the last home on the street. What happened in Gary, South Dakota? Is there some lore I'm missing or something? You got me wondering what's going on with Gary. Why does that sound familiar, though? It could just be going right over my head. Probably is. But anyways, y'all, like I said, if you guys have any questions, please do not hesitate to ask. We are more than happy to help you guys. I'm going to bring up the current reflectivity, too, from MRMS. We're going to get rid of this here. So it looks like the snow has slowed down quite a bit up north. Still do have a bit of snow showers up in like upper Great Lakes area, northern plains here. A little bit of snow up by Nebraska too. You know what? We do have a little bit of storm activity over like Kentucky too. What's the environment looking like right around now? Curious. Okay. Very interesting. Yeah, like I said, what's really interesting is the the morning convection that we have here. This little cold core setup we have. I mean, like I said, 850 to 500 millibar lapse rates. Between these two layers here. I mean, that is 7.8 degrees Celsius per kilometer. So that means, like I said, for every kilometer up in altitude, the temperature changes 7.8 degrees. So for my American folks, right? Nope, I clicked the wrong thing. Let me bring up our units here. So, okay. So for every 10,000 feet, sorry, every 1,000 feet, my bad, the temperature is changing 2.4 degrees Celsius. Now, if I was to do a conversion, Celsius to Fahrenheit, so we'll do 2.4. Okay. Wait, hold on a minute. This isn't right. Okay. Anyways, but basically the temperature is dropping off really quickly over altitude. Andy says, "Do I think I'll need to worry about any tornadic activity near Wheeling, West Virginia?" Let me pull up Wheeling. Let's see what we got going on here. I'll do a bit of a deep look for you. Wheeling. Oh, you're like extreme northern West Virginia. Gotcha. Well, the first thing I'm going to look at is to see if SPC has you under any risk for today. Tornado. Okay, believe it or not, Wheeling is actually outside of the tornado risk area. We are barely included, though, in the level 1 threat for severe weather today, which actually the only reason you're in that severe risk today is for hail. It's very interesting. Very interesting. Anyways, here, let me bring this back up here. We're going to go to models, precipitation, composite reflectivity. So yeah, we could get some storms later on this evening here, or this afternoon, evening. Okay. So we do have a little bit of a curvature to our photographs here. I mean, you can see that we do have a little bit of veering winds. However, they do appear to be very weak. These veering winds appear to be pretty darn weak here. I mean, at least from a sounding like this, probably not. Also, given that these storms are very elevated too, it looks like. Meaning the storm base is pretty high. I mean, in this case, we're roughly about 5,000 feet or so storm bases. I mean, you really want that like 1,000, at most kind of like 2,000 for tornadic activity. I mean, given that our storm bases are about 5,000 feet, that's pretty high, pretty elevated. So not only is the storm elevated, but the lower level winds in general are pretty weak anyways. Yeah. I mean, at least here I don't see that. Maybe if we go later on into the evening, no, we start to cool down pretty quickly. Nah, I don't think you're gonna get any tornadic activity out here. It definitely looks to be pretty elevated for your area. Let's see here. Angela says, can I see how my area would be later today whenever my city gets stormed? I'm very curious, only because of the mixed info from many people. Sorry for repeating my first question. That's fast enough. No, you're good. Let me know what area you're in, and I'll be more than happy to. Did you mention it beforehand? I don't remember if you did or not. Yeah, just let me know, and I'll be more than happy to look for you. I will tell you though, I mean the models are a little iffy. With the whole timing thing and everything like that. Once again, the HRRR wants timing a little bit different than the RRFS. I mean, it seems like models are a little iffy, so we're just gonna have to kind of just see what happens. But I mean, the environment's relatively similar. It's just where those storms fire off here. Lansing, Illinois. Gotcha. That's right. All right. Well, let me pull this up for you, my friend. Oh, you know what? You're up by Chicago. So the thing about you is, given that you're high up north, there's not as much moisture as opposed to areas further south of you. That's a good thing. To help against storms, you want less moisture. So Lansing is right. It should be like right in here, right? Oh, there we go. So there's Lansing right here. Gotcha. Okay. It's generator sounding here. I'm curious to look at the environment. All right. So as our FS model, as we go down through time here. Okay. So the ground is going to be too cool for traditional severe weather setups and stuff like that. Even if we were to get storms, they would be elevated. So that already knocks out your tornado threat. I don't see any tornado threat for you. Yeah, honestly, I mean, here, let's pull up the composite reflectivity here from the model. I'm curious to see what it shows. So it does show some showers. I mean, maybe a couple of rumbles of thunder. But honestly, the main threat is mostly south of you. Here, let me pull up SPC. Let's see what we got going on here. Yeah, I mean, so you are in a level 1 threat from the Storm Prediction Center here, but yeah, as I expected, the tornado threat is south of you. So you don't have a tornado threat. Hail, we have a little bit of a hail threat, barely. The main thing is gusty, or sorry, I got that mixed up. Hail is your main threat. Yeah, I mean, yeah, given how cold it is up there, especially in our mid levels. Here, let me grab another sounding here. I'm curious to see. Let me go back to default here. So we do have some pretty steep lapse rates. Like I said, the rate at which temperature decreases with altitude is pretty steep for some of your area, like right above you, which could allow for some elevated storms. So just potential for storms, yes. Not a tornado threat, not even really a damaging wind threat, but yeah, elevated storms like that in this environment could produce a bit of a hail concern, which I do see why they put that, to be honest with you. So yeah, I mean, I don't think it'll be anything significant though. I mean, it's not really anything that I would drastically worry about. So I love my city. Well, I'm glad you do. But yeah, I think you'll be all right. I think everything will be okay out there. Give or take maybe a couple elevated storms, but I mean, hey, other than that, at least you're not in the big stuff, So that's good. What's up, Overbuilt? Good to see you. Saying good morning. Good morning. Hope you're well. Hope all is good. But yeah, I mean, really the main difference now, the big thing now is the models are kind of suggesting maybe late evening, early tomorrow morning, we might even develop a little bit of a line of storms, which most will probably not be anything significant. So then we go into Friday. We get some more moisture advection here. In the later Friday, we do get some more storms fired off here, kind of across the lower Midwest, bits of the southeastern U.S. here. Then we go into Saturday, which, we could see some more storms in the southeast here, which I mean, I see why. So the photograph looks like one of those loopy plastic straws from those cups I had. Yeah, they do, don't they? Some of them can. Absolutely. It's pretty funny. I remember, I don't know why this reminded me of this. When I was a kid, I don't know if any of you guys remember these, okay? When I was a kid growing up, we used to have these things called zoo pals, which were like those little paper plates of different animals and stuff. I don't know why you saying that straw made me reminded me of that. I literally haven't thought of that in over 15 years. That's crazy. That's crazy. Anyways, here's a current radar view, y'all. So this is what's going on now. What we were looking at previously was forecast, and so now we're looking at the current radar. We are seeing severe thunderstorm warnings in effect for Huntertown, including Leo, Cedarville, Grabille, Spencerville. So this is a severe thunderstorm warning in effect here for quarter-size hail. We could see some gusts upwards of 50 miles per hour in the storm here. Not necessarily severe, per se. For be classified as severe, it has to have winds of 58 miles per hour or more. Don't ask me why it's 58 and not 60. I don't know. Probably extensive wind tunnel testing. They probably figured out that 58 was like a breaking point or something. I don't know. But yeah, 58 mile an hour wind gusts or more is, or winds or more is considered that. Crazy straws. Are those like those loopy straws? Yeah. Oh yeah, I remember those. But like I said, yeah, this is a bit of a cold core setup. Once again, we do have some pretty steep lapse rates, which is really generating these storms here. I mean, which is really helping. See, Carrot says you were cool if you pulled up with those crazy straws. Yeah, that them in those barrel drinks. You know what I'm talking about? What are those things called? Shoot. You know what I'm talking about? Those barrel juices. Those things too, man. I used to love those. Do they even make them anymore? Goodness, man, you're bringing back some flashbacks. I mean, just from those straws alone, man, I'm getting like a flashback thing over here. Anyways, here's a sector scan of those storms here. Seems like the precip core goes up to about 30,000 feet or so, which, yeah, I mean, that's about what the soundings kind of suggested here, too. 30,000 feet or so. Let's just grab a sounding roughly out here. So right now it's 630. Equilibrium level is, let's see. This one's showing 18,000 feet. I mean, it's definitely not a one-to-one to real. Interesting. Huh. Yeah, and of course, models are not perfect. Obviously. We actually did just get a little bit of a hail report in that storm here. 0.75 inches. This is southeast of Huntertown. What's up, Haley? Good to see you. Overbuilt said I'm a bit too old for those. I do remember pound purries and little stuffed dogs and what? Oh, nice. I have never even heard of those. Carrie, you remember the barrel cups? Yeah, those juices. They were so good, dude. Dude, it's bothering me. What were those things called? Hold up. They were popular in like the 2000s. Barrel, drink. What were those? Hugs. They were called hugs. That's right. They were these things right here. You guys remember those? Whenever you said straw, that's what it started bringing me back, man. Now with 75% less sugar. They took the fun out of it, you know? Man, I really wonder if they still make those things. And I wonder if they still taste as good as they did back in the day. Anyways, once again, y'all, severe warning in effect here for quarter size hail. Wind gusts up to 50 miles an hour. That's the only severe warning we got. We do have a lot of lightning activity, though, still. Do I have any Indiana cams? Hold up. I'm about to see. I want to see if I have any cameras I can pull up. The blue is the best. I 100% agree. Absolutely. Those were gone first. Ooh, hold on a minute. Are these? Oh, buddy, we got some live cams coming up for y'all. Oh, let's go, dude. Haley says, "Is that a fireplace behind?" It's my TV with a fireplace. All right, y'all. We got some camera action coming on now. Maybe. So many cameras to choose from. Maybe if any of them loaded, that would be nice. See, that one doesn't load. Maybe this one. I wonder why these ain't loading. Hold up. This is for, yeah, Leo Cedarville. Yeah, it seems to be up to date, actually. Well, darn. Well, isn't that just a party pooper? Nothing but buffering on these cams, man. Yeah, I agree, Carrot. I agree. Well, I thought I had some cams for y'all, but they decided not to work, so I'm sorry. All right, it seems like the hail core in this one cell, hopefully, is dying down a bit. Like I said, we did actually have a 0.75-inch hail report from the public in Allen County, Indiana. Time at 10:55 UTC. 0.75 inches. That's penny-sized. That is penny-sized hail. We actually had quite a bit of hail reports before that, too. We had a 1-inch hail report southeast of Columbia City here. This was from a National Weather Service employee here from Whitley County, Indiana. Off-duty National Weather Service employee reporting lots of mainly pea-sized hail with a few larger pieces of nickel to quarter size noted. We had another report out by South Whitley a little bit ago. Let's see, at 10:32 UTC, penny-sized hail, 0.75 inches. Video and pictures shared of at least penny-sized hail in South Whitney. So, I mean, we've had quite a handful of reports here. Here's another one in Cass County, Indiana, at Hoover. This is at 9:30 UTC, so this was obviously a while ago. Huh. No, you're good, Everbuilt. Don't worry about it. You are good. You are good. But anyways, y'all. Yeah, I mean, look how many warnings we had earlier. I mean, comparing to now, we only have the one, so things have definitely calmed down a bit. I'm really curious to see if those storms are going to fire off because, like I said, these storms, the models did not pick up on. Once again, this goes to show you models are just good tools to help us guide, or they're good for guidance, but they're not good for fully trusting because, yeah, we had some storms here whenever the models didn't even pick it up. I mean, not even the HRRR, not even the RRFS even picked up on these guys. It did show some convection in the later morning, more like 7, 8, 9 o'clock or so. So who knows? We'll have to see if we get any more than that. Hard to tell. Yeah, it seems like they're starting to kind of fizzle out here, They're starting to die out here. Maybe that little bit of the environment has been used up already. It's really, really interesting. But anyways, if you guys have any questions, be sure to let us know. Like I said, we're here for you guys. We'll keep you guys up to date with everything. I'll be sure to help y'all out with severe weather and stuff. Like I said, I think I'm going to cover later tonight. We'll probably cover the later portion of the event. That way I can be here for the nighttime side of things. All right, let's bring back up our future radar. Yeah, I mean, you could see how most of the cell activity, most of these storms fire off here kind of between like 1 and 3 p.m. according to the RRFS model. And then a lot of it should be, I mean, it'll continue into the overnight hours. Still a little bit of storm activity there, here and there, but yeah, the main part of the event here is going to be through through the later afternoon through the evening. I mean, like I said, the wind shear seems to be pretty good. The lower level winds really. I mean, if we were to overlay these here for later this evening, I mean, you can see that we have really strong lower level winds, about 50 or so knots. So really strong winds going northeast. And, if I was to just say grab a bit of a sounding kind of out by Bowling Green here from the RRFS at 10 o'clock. Wow, look at that photograph. Yeah, you see that? Holy cow. So that's telling me that the winds are not only increasing in speed as we go up in altitude, but also changing direction from the north to the northeast. Effective inflow layer storm relative helicity is 509. Wow. That's pretty darn high there. Let's see, our dew points in the lower 60s. I mean, not an absurd amount of instability, but enough, dude. I think this is one of the more aggressive one of the more aggressive soundings that I've collected here tonight, or this morning. Goodness, look at that. So that's for 10 p.m. And storm mode in that sounding does seem to be, I mean, you can tell it's wanting to form a line, but it's still pretty broken up into maybe some semi-discrete severe storms. But yeah, that really shows you the environment, especially in the evening. Because for the afternoon convection that we do get, we will have some decent lower level winds in some spots, but the full primed environment's not going to be until the evening here for today. Overbuilt says, I did hear a comment the other day. A guy was saying that AI is ruining weather forecasting. Something about AI models change too much, too fast. Any ideas or thoughts? It's a pretty bold claim to say they're ruining. I mean, if you don't like the AI models, just ignore them. I mean, some people probably like to use AI models. I personally don't. But I mean, if you're talking about AI forecasting or just AI in general for weather, I don't know. It's gonna be kind of hard for AI to take over weather reports and weather coverages and stuff like that. But see, guy was most like just talking to hear his own voice as far as weather goes, not his thing of knowledge. Oh, gotcha. Yeah, I mean, I personally, like I said, I don't really use the AI models that much. If I do, it's for redundancy, just to see if there's other support from other models. Like, for example, the precipitation, which I'll pull it up real quickly. The precip type comparison. I'll bring up that little bundle I have here. Precipitation should be actually right here. Yep. So I have 5 models here. And the AI models are on the bottom, but the main models are up top. I think I've noticed the AI models are very low res. Also, for that northeast system here, I mean, it seems like there's a little bit of support. But in terms of what's happening, I mean, the models are That's interesting. Here, let me pull up the RRFS model here. We should have enough guidance to where we get to part of that event with high-res model data. I really want to see the RRFS model opinion here. Here we go. Go back to 6 UTC. It doesn't even really show it. That's interesting. Yeah, I mean, the max RRFS just shows maybe a bit of lake effect snow from the cold air mass rolling over the Great Lakes, but yeah, about that crazy nor'easter people were talking about. I mean, this model doesn't really pick up on it. Although it is kind of at the beginning of it, but I mean, we'll see. I do see a bit of snow, though, going over the northeast here for kind of Friday. Yeah, Friday. Really coming down by Friday evening, it looks like. I'm sure the HRRR agrees. Yeah, I mean, usually just the existence of a storm, the models can can do pretty good on. Yeah, HRR agrees 100%. Yeah, I know a lot of the upper Great Lakes got some pretty good snow from this last storm. I mean, they're going to have a little bit more to add to even areas like Iowa is going to be seeing a bit of snowfall. Wisconsin. Some of it will start to transition into let's see here, into Michigan. Excuse me. Why is Shotcut and testing my environment while I'm streaming? No, dude. Thank you. Carrot says, saw someone say I only used a RRFS when I lose hope in severe weather setup. They only use the RRFS. Why? I mean, you see me here. I use RRFS quite a bit, but I also use HRRR. It's like I said, it's good to get different model opinions. You know, I do like the RRFS. I ain't gonna lie though, it's pretty solid, and I'm pretty sure the RRFS is more of a newer model. I think this. Somebody correct me if I'm wrong here. I'm pretty sure the RRFS is supposed to replace the NAM. I think that's the model that's supposed to replace it, because sometime soon, I don't know when, but they said early 26, we're going to be losing the NAM models, unfortunately, even though they're kind of atrocious sometimes. Like the NAM 3 kilometer, during tropical activity, you see almost every tropical system go down at like the 800 millibar range. Not really the best. It also kind of overdid. It made every severe weather event a squall line. Yeah, that was something. But yeah, I think we're going to be losing the not the HRR. Sorry, we're going to be losing the NAM here fairly soon. All right, let's sync runs. We'll sync layers as well. So hopefully that'll work. I mean, anything can replace the NAM at this point. That's true. You know what? You're not wrong there. Like I said, the NAM is kind of atrocious. It's kind of atrocious. I ain't gonna lie. I'm gonna miss it though, just to make fun of it. You know, I'm gonna miss that a lot. I mean, that's been a thing since I started years ago. Good morning, Christy. Hope you're doing good, my friend. Good to see you. Haley says, Andrew, why are they replacing the NAM? I think it's outdated. And obviously it's an atrocious model. Yeah, like I said, man, you know, with tropical systems especially, you really see the dark sides of the NAM model. I ain't even kidding. Most tropical systems, whenever you look at the NAM, especially the NAM 3 kilometer model or NAM Nest, pretty sure that's the same model. But you would literally see every single tropical system with that model getting down into the 800 millibar range for that central low. Even if it's like only supposed to be like a tropical storm or something, it's like, oh, I'm gonna make that like 870 millibars, typhoon tip moment. Anyways, all right, severe warning in effect. It's actually moving into Ohio now, northwest Ohio. So for Ohio, the current towns in the warning include Hicksville, Cecil, and Antwerp. So you guys are under that. Now for the Indiana side of the warning, including Newville, St. Joe, Spencerville, Leo, Cedarville, and Greville, I think it is, we have quarter-size hail and wind gusts upwards of 50 miles per hour. So not really damaging winds or anything like that expected with that storm, but you know, a little bit of hail. Like I said, we have a little bit of a cold core setup this morning out here. I mean, like I said, the dew points are literally like in the 30s, and the temperatures are in like the upper 30s, lower 40s. But that those really steep low mid-level lapse rates are really coming in clutch here with these storms here. Let's see here. Carrot says everything. Let's see. Discrete environment or line storms limited instability without. Nah, it's duration. Yep. Yep. Like that's what I was saying. It's like almost with the NAM nest or the NAM 3 kilometer model you'd use. Say you actually have a discrete supercelled environment with a bunch of just cells here and there, right? NAM would be like, no, it's gonna be a squall line. What are you talking about? Every time. Matter of fact, I'm curious right now. If I was to pull up the NAM, I wonder if it would do it. Hold on a minute. I'm curious. I'm blowing the dust off of COD meteorology. This is ancient software I used to use. This is actually, I think this is the first set of models or the first site I used for weather models. Oops. I mean, this goes back to like 2016, maybe, when I started looking at COD. All right, let's do NamNest. I just get the chills even clicking on that. So in this case, the NAM nest doesn't even hardly even shows any true like isolated supercells. It's literally just all a bunch of popcorn cells firing off here. I ain't even gonna lie with you. This is the most realistic the NAM has ever been that I've seen. I'm not even gonna lie with you. That is interesting. What I'm gonna look back. Like we're gonna go back 24 hours ago. See where it was at then. Yeah, I don't know. But usually it's for any like springtime setup. Typically, you'd really see that. Anyways, but yeah, those were the days, But once again, if you're just tuning in, first of all, welcome. Good to see ya. If y'all are enjoying the stream, be sure to leave a like, hit that subscribe button. If you are new, it'll be much appreciated. Like I said, we do got a severe thunderstorm warning in effect for Northwest Ohio, Northeast Indiana. For Indiana, this includes Leo, Cedarville, Grab Hill, Spencerville, St. Joe, and Newville. For Ohio, it includes Cecil, Antwerp, and Hicksville. The warning is in effect for quarter-size hail, which is 1 inch in diameter, and potential gusts upwards of, 50 miles per hour, upwards to 50. 50 or less. Less than 50. But you know what? We're actually seeing a little bit of lightning activity, though, with this storm here. Although it does kind of seem to be losing. I mean, it's not in its prime anymore. I mean, you could see here earlier where it had a decent little hail core there. I mean, now looking at it, it seems like it might be weakening a bit. So we'll have to see. I'm not sure how long they're going to keep that warning there for. But yeah, I mean, typically when your updraft weakens and stuff like that, whenever whenever the storm is dying, sometimes it just dumps all of the hail that was lofting to the ground because the updraft can't support the weight of the hail any longer. So that's probably why they still have that warning in effect, just to let the storm kind of bleed out before they pull it. Which, I mean, more than likely, that's probably what they're doing here. Although we do have a few new cells looking like it's trying to develop south of Miller City, Ohio, out there by Ottawa. Very interesting. Carrot says NAM, never accurate model. Absolutely. I always love those acronyms. I came up with one for PDS. So for particularly dangerous situation, I always said, please don't scream. Which means pretty valid. Pretty valid. Anyways, those storms do appear to be weakening, which is good. Definitely thankful about that. But, if we can get some cloud clearing before these storms fire off here, we're going to have, a better shot at more deepened severe weather today. Let's pull up. Actually, you know what we're going to do now? I'm going to pull up most unstable cape here. Let's do that. Let's do most unstable cape. Actually, no, I'm gonna do surface cape. We're gonna really look at the ground or close to the ground here. Surface base cape. Here we go. Here we go. Now we're talking. All right, so we'll bring that up. Like I said, we'll also overlay our lower level winds here too. Do upper air. We'll do 850 millibar winds. Yeah, in the later part of the event, like I said, those lower level winds are going to really start ramping up. Really, really start ramping up. In the afternoon convection here for, this afternoon, the models kind of suggest the lower level winds about 4,000 feet to be between 20, maybe 30 knots or so, locally higher. But, once we get into the evening, with the evening convection, it shows like 45, 50 knots or greater in lower level winds. And like I said, these lower level winds are very important, not just for the organization of severe weather, but also for like tornadic activity, because it helps create that spin that's needed for those tornadoes. Like, I'm going to grab a sounding here. Like I said, the veering winds, the sudden change in wind direction and increase in wind speed in the lower atmosphere really plays a very important role in how tornadic activity could form, which, you can kind of see from the photograph here. We have a little bit of an arch. It's not like your perfect, fully symmetrical, I guess that's the word for it, arch there, but there is definitely some veering. So here on the ground, the winds are pretty much moving northeast, maybe north-northeast, and then you go up in altitude and the wind direction changes a little bit more to the east. And at this point, too, the wind speed is increasing, too. Like, the higher you go up, the stronger the winds do get. So that's very important. Like I said, also storm the storm base height, really using like the LCL, which is the lifted condensation level, which is basically just the base of your storm here, which shows about 2,800 feet. Still maybe a little high. You want that base to be as close to the ground as possible for tornadic activity. Christy says, I'm like a walking zombie making coffee. Great use of simile there. I do get it. It is pretty darn early in the morning. Holy cow, we've been live almost 2 hours here. That's crazy. Haley says, I don't trust the NAM model because it's not accurate. Yeah, usually. Usually not very accurate. No, but I could totally see why they're getting rid of it. I'm pretty sure a lot of it is that it's outdated. Matter of fact, I'm actually curious. When did the NAM model come out? Let's see. Wow. Okay, you can say it's outdated. Holy cow. All right, y'all. Without Googling it, how old do you think the NAM model is? the one that's about to retire. You have 5 seconds to put it in chat. All right. It came out in 2006, apparently. The NAM model. I think GFS is older, isn't it? I think they just upgraded different versions of GFS over the years. Yo, this is crazy. Dude, the GFS came out in 1975. Yeah, the new GFS has got to be like a obviously an upgraded version. I want to see what the 1975 model looked like. I ain't gonna lie. 1975. Let's see here. GFS model, weather model. Who knows what pop-up if I pull that up. All right, let's see here. Doesn't really show. That's boring. I'm sure if I did a lot more deeper research, maybe one day I'll do like a little video or something on history of the weather models or something. I think that'd be pretty cool. I do know that they used to like print them out on paper, like these big sheets of paper, instead of, before computers became a really big thing. They used to do it with a pen and paper, which is kind of crazy. That's pretty wild. Maybe I think that's a good video topic one day. I need to do some research, and then I'll make a video talking about the history of weather models. I'm gonna have to remember that. If anybody's in the stream right now who's in my Discord server, ping me. Let me know. Remind me to do that so I can add it to a list. Because you know what? Actually, I do have a post-it note here. That might actually work. Hold on. I'm gonna use my comically large Sharpie to write this. Forecast model history video. There we go. Yeah, I think that'd be pretty interesting. I'm sure I could pull up some old model data or something, maybe. Anyways, new update on that severe thunderstorm warning. They canceled it for Indiana, including Newville, St. Joe, Spenceville, Leo, Cedarville, and Grabille. However, it's still in effect. Severe thunderstorm warning in effect for extreme northwest Ohio, including Hicksville. That's the only area that is in the warning as of now, which this is for quarter-size hail, which is 1 inch in diameter. We shrunk the warning. The storm almost dead. You can finally go back to bed soon. Yeah, I probably will. I don't think I'm going to be on here too much longer. I mean, shoot, we've been live an hour and 48 minutes on the dot. Christy says internet came out in the 60s, or at least the beginning phases of it. But it wasn't given for general use till the 90s. Yeah, pretty much. Yeah. I mean, the idea of transferring the idea of transferring files between computers has existed, since probably the 60s. But yeah, I mean, typical, whenever you think of internet, you think of like surfing the web, like, how they used to say it. But like, going on a internet browser or whatever. Yeah, that started in the kind of the early mid 90s. Yeah. Kirsty says, I graduated high school in 06. You know how old I was in 06? I was 4 years old. I was 4 years old in 06. I wasn't even in school yet. Man. That's crazy, though. But I still can't believe. I mean, I'm about to turn 24 in April. On April 2nd. Almost April Fool's. I was almost an April Fool's child. That would have been a disaster. But on April 2nd, I'll be 24. 24. How much longer we got on this warning here? I'm getting sleep deprived and it's showing. 7:15 a.m. Okay, so we still have about 11 minutes left. I'll be here till that warning expires, and then I'm gonna call it. I don't know if they're gonna cancel it before it expires, or excuse me, or if they're going to just let it run out. But like I said, still quite a bit of lightning activity in it, though. Very electric storm. All right, let's hop back to models while we wait. Here, let's actually, you know what we're gonna do? We're gonna look at the modern, or not the modern, the newer models here. Here's the 10 UTC run here, because interesting. So the new HRRR shows obviously a couple of cells in which could be pretty strong, maybe some supercells, but still showing a lot of scattered convection here. Chris says that's about right. I'm 37 in May. I'll be 38. I gotcha. Gotcha. Yeah, honestly, I mean, it's just crazy how fast time is flying. It literally felt like I just turned 18, and now I'm already 24 almost. It's like, dude. Crazy. You know what, though? The new HRRR still shows that line developing in the late evening. Let me grab another sounding here. I'm curious. Yeah, the environment still appears to be severe in this case. Let me go down towards Tennessee. Yeah, not a lot of instability, but there's some good moisture still. Really strong wind shear. I wonder if they're going to expand that threat southward. Chris says it means I'm old. Thanks, chat. Nah, you're not old. You're not. Here, let's bring up RRFS. Yeah, the latest 10. We'll go back to. We'll go to 06. Yeah, I mean, the 06 RRFS. Let's see what the environment looks like here. There is a little bit of a capping inversion, but if we have good enough lift, I mean, in theory, it could shoot right through it, but still good dew points, really strong wind shear, enough instability for storms and stuff. I don't know. I wonder if they will extend that threat further south into deeper into Tennessee, West Tennessee, anyways. Yeah, by the time we get to East Tennessee, a lot of the instability is used up for. Because I mean, yeah, that's kind of a new addition since we were looking at the models earlier yesterday. Like that line mostly wasn't there. But remember, guys, I mean, it seems like this storm is gonna be firing off here. Pretty much in the early afternoon, anywhere between 1 and 3 p.m. See, Carrot says last year it was so dead in Ohio. This year is starting off better. I gotcha. Is it? It's bad that I have a hard time remembering, that stuff, man. It's crazy. Like I am really bad at remembering past severe weather events, unless they were like super significant. Either that or I was involved directly in them. But yeah, I mean, I have a hard time with remembering a lot of past events. Which is also kind of good, about this channel too, is like, say I want to go back to a weather event like 2 years ago or whatever. That I could just go back to my streams and kind of look at, before the event to see how the models were, and I can just really kind of look and see how it evolved, which is pretty cool. Haley, I don't know. You're gonna have to go back on my streams and look, but probably did. I mean, I covered a lot of events. Where is that red pen? Shoot, I accidentally got rid of the red pen. You talking about this little guy right here? Yeah, it was a marker I have. Do you know where we're looking at on the map here? Like here's Kentucky. This is Kentucky. This is Indiana. This is Ohio. Never mind, you moved. I'm sorry. It could have been. I was honestly looking in Tennessee there for a little bit. That's where I was looking at for convection. That's what I was wondering, if they're going to extend that threat further south. Let's see. Yeah, we have a general thunderstorm threat here. I really wonder if they're going to add a little bit of southern Tennessee, or sorry, western Tennessee in this. It was in Kentucky middle. Oh, gotcha. Yeah, I did look at Kentucky. When the convection started, between like 1 and 3 p.m., it shows a bunch of scattered cells popping off. All right, we still got that severe warning. Should be canceling here very, very soon. Let's see here. This is a severe thunderstorm warning in effect for south. Severe thunderstorm warning for northeastern Allen and southeastern DeKalb counties is canceled. Has moved out of the warned area, therefore the warning's been canceled. Gotcha. I think that was probably for the previous location. And I think that's Indiana. Pretty sure. But yeah, there we go. Still remains in effect until 7:15 a.m. Central for Paulding and Defiance for quarter hail, which includes Hicksville. Let's see. Jack says, "Can I forecast a time when the storms will hit me?" Yeah, I mean, I can give you a rough estimate, but you got to remember this is a kind of a tricky event to forecast timing for, because it's a bunch of scattered storms. First of all, we don't know exactly. I mean, we know the general area where these storms will be at, but nature will take its course and will fire off storms anywhere it wants to, while models don't always pick up on it. Anyways, but yeah, you're up here by. You're not too far from Indianapolis. You're south of Indianapolis here. Okay, so. The main bulk of storms, according to this model, appears to be coming through kind of in the evening. I'd say anywhere from 6 to 10 o'clock p.m. is when you could really start to see some of these scattered storms in the area. I mean, it's definitely possible for the later morning, early afternoon to maybe see a couple storms out here, just given how they're not perfect. But yeah, probably sometime in the later evening is when you'd experience those. So that's based off of like the RRFS there. Carrot says new special weather statement for it, so it's done. Yeah. Usually when they do that, then it's gone below severe limits. All right. Well, I'm probably just gonna call it now then. Hey man, at least we did a little bit of cold core coverage. Didn't see that in my Uno cards here for this morning, but there we go. We had it. Anyways, little storm has been developing pretty quickly over West Kentucky right now. So scud clouds, really. Let's pull up maybe Paducah radar. Oh, is it this little guy? By Blandville. Very bland little storm there. And it seems like a little chicken nugget of a storm. Not severe right now, though. But definitely interesting. Haley, you're not in the threat for general thunderstorms today, so you're good. We do have a threat tomorrow. Not for you, but for bits of the South here. We actually have a marginal risk now tomorrow too. Then day 3, even bigger marginal for the Southeast here. But no, at least for the next 3 days, no, you're not in the risk here. For even general thunderstorms. Christy says, thanks, Andrew. Of course. No problem, Christy. Of course. But yeah, I'm probably going to call it a stream now. I'm getting a little sleepy. Like I said, I've been on total night shift here for the last little bit. Actually, you know what? I think that warning got expired. Yep, sure did. Well, there we go. There is currently no warnings in effect here. That is a good slate to call it a stream on, you know. But yeah, I've been total nocturnal. I've been total night shift mode for the last like several days. I've been like awake most of the night, asleep during the day, which is, like I said, it's got me a little concerned about coverage tonight because I'm going to bed soon. I should be up to at least cover the later portion. That's what I'm saying. When I cover the later portion of the event for the nighttime portion, so we won't be live in like the early afternoon or anything like that. No, we'll be live probably in the later evening for you guys. But if you guys did enjoy the stream, be sure to leave a like and hit that subscribe button. It'll be greatly appreciated. Much appreciated. And thank you for everybody who has supported us directly. And thank you everybody who has hung out here tonight with us. Greatly appreciated. And see vampire schedule. Yeah, absolutely. Thank you, Haley. I appreciate that. Peachy, you were just now joining when we're ending it. Yeah, we're heading off here now. We've been live for 2 hours. 2 hours. A bit of a late stream. But do I blame you? I mean, I'm sure you're sleeping. So not really. But if y'all have any more questions before I roll off here, I'm gonna go ahead and give a once going twice type of thing here. So if y'all want me to look at anything else in the models or anything on the satellite or whatever is any product, let me know. But if not, then I'm probably gonna head on off here. Probably gonna get something to eat and lay down and go to sleep. But like I said, just try not to worry about the storms. I know they're a little intimidating, and I know it can seem a little scary, but we'll get through this. We'll be all right. We'll get through this severe weather event, and we'll be sure to help you guys out. Peachy just woke up. Yeah, I figured so. But all right, everybody. Well, I just want to say thank you all once again for joining. Thank you everybody who supported us directly with donations and stuff like that. It's greatly appreciated. So big shout out to you guys. Thank you for everybody who has stopped by this morning and just in general. Thank you for hanging out with us, and thank you to the mods, including Peachy, even though Peachy just joined here. But I appreciate the mods for all the help and support that they do as well. And alrighty. Thank you guys so much for joining. We're going to go ahead and call it a stream for now. Haley says, what's my thoughts on tornado season coming up? I think it could be pretty active in the Gulf states, but I'm not going to go too in depth with that right now because sleep is calling my name right now. So, all right, everybody, you guys take care. Have a great night. Thank you all for joining. We'll see you guys here later on today, actually. We'll see you guys later on this evening for some more coverage, actually. All right, everybody. Thanks for stopping by. See y'all in the next one. Peace out, my friends. See ya later on.